Hello everyone. Second lecture of engineering mechanics. The learning outcomes are significance and relevance of mechanics, applied mechanics, static, dynamics, space, time, mass, particle, flexible body and rigid body. Okay, in these sections I will briefly discuss about the unit 1 basics of mechanics and force system, and the first topic is significance and relevance of mechanics. So engineering an activity concerned with the creation of new systems for the benefit of mankind. The process of creativity proceed by way of research, design and development. New systems emerge from innovation and system may be constituted by mechanical, electromechanical, hydraulic, thermal and other elements. Creation of new systems is thus basic of all engineering. The Living Webster Encyclopedic Dictionary defines engineering as the art of executing a partial application of scientific knowledge. It is important to understand the difference between engineering and science. Science is concerned with a systematic understanding and gathering of the facts, laws and principles governing natural phenomena. Engineering, on the other hand, is an art of utilization of the established facts, laws and principle of create certain desired phenomena as shown in figure 1.1. So first of all, so here is the role of engineering mechanics is the nature. So now come to discuss here the first point. So what is nature? In some society, there is no concept of nature nor any concept of what is not nature. So whether culture or society of humans, so why do we need a concept of nature? When we grow crop, are we deals with nature or something that is not nature? So everything we do every day in a mixture of things that our school teachers told us are supposed to be separate. Our school teachers told us that behind all the different things that human beings do, there is an unchanging background consisting of things like atoms, genes, and energy. The next is your science. So science is not an encyclopedic body of knowledge about the universe. So instead it represents a process for proposing the refining the theoretical explanation about the world that are subject to further testing and refinement, but in other to quality as scientific knowledge, an interface of assertions must be derived by the scientific method. And the next is your basic science and physics. The basic science are defined as the scientific disciplines of mathematics, physics, chemistry and biology. They are called basic science because they provide a fundamental understanding of natural phenomena and the process by which natural resources and transfer. And the physics is a natural science that deals with matter and energy and interactions of matter with one another. It also deals all physical process and phenomena of a particular system. And the next is the fact, law and principle. So first of all, so now what is the facts? So fact in science, an observation that has been repeatedly confirmed and for all practical purposes is accepted as true. Truth in science, however, is never final, and what is accepted as a fact today may be modified or even discussed tomorrow. The law is are descriptive generalizations about how some aspect of the natural world behaves under stated circumstances. Various laws you already study in the school period like Newton's law of motions, law of conservation of energy, Hooke's law, etc. And now come to the principles. So principles are ideas based on scientific rules and laws that are generally accepted by scientists. They are fundamental truths that are the foundation for other studies. They are more like guiding ideas that scientists use to make predictions and develop new laws. So various principles you already studied in the schooling period like equivalence of principles, Archimedes principles, etc. And then terms is your engineering science, so that is the mechanics. So engineering science, that is mechanics, is a broad discipline that encompasses many different scientific principles and associated mathematics that underline engineering. Mechanics is the study of force that acts on body and the resultant motions that those body experience. So basically you have to study at present time of the engineering mechanics. So now, so I will explain here. So already what is engineering mechanics? So engineering mechanics is the study of forces that acts on bodies and the resultant motions that those bodies experience. The next term is your engineering. So engineering is a use of scientific principles to design and build machines, structures and other terms, including bridges, tunnels, roads, vehicles and buildings. The discipline of engineering encompasses a broad range of more specialized field of engineering, each with a more scientific emphasis on particular area of applied mathematics, applied science and type of application. So the role of engineering mechanics is the nature, then science, then basic physics and physics, facts, laws, principles, engineering, science and mechanics, engineering, then after the new features developed here, the new systems. So the activities of science and engineering are thus mutually opposite. Both may proceed through similar ways and means of analysis and synthesis, but are oppositely directed. The training of scientists and engineers should be correspondingly designed for their respective objectives. The set of course meant for engineering students are called engineering mechanics. So these are essentially basic science classified and labeled especially for engineering students with regards to their future responsibility. The existing law and principles are conveyed to the students by the engineering mechanics course, and emphasis is laid on their application to real life problems. So mechanics is the physical science concerned with the dynamical behavior of material bodies in the presence of mechanical disturbance. Since such behaviors is of interest to mechanical, civil, electrical, chemical, aeronautical, textile, metallurgical, mechatronics and mining engineers, it is appropriate to conclude that the subject of mechanics lies at the core of all engineering analysis. Engineering mechanics refer to a course in mechanics tailored exclusively for engineers. Essential features for such a course are: the subject matter is not presented as rigorously as a course of analytical or axiomatic mechanics may demand. On the other hand, the contents are not just a series of applications as implied by applied mechanics, but a through grounding of the basic principles together with engineering application. The course integrated to provide a sound foundation in engineering science. The course comprises the foundations for a number of courses that are to be built upon it. Some of them are shown in figure 1.2. So here is the mechanics are the foundation of the number of courses. The foundation of engineering mechanics, laws and principles, engineering, fluid mechanics, continuum mechanics, mechanics of solids, ideal fluids, viscous fluids, compressible flows, aeromechanics, viscoelastic fluid, then mechanics of deformable bodies, partial mechanics, rigid body dynamics, rigid body statics. So after the completion of significance and relevance of mechanics, the next topic is your applied mechanics. Applied mechanics is the branch of science concerned with the motion of any substances that can experienced or perceived by human without the help of instruments. In short, when mechanics concept surpass being theoretical and the applied and executed, general mechanics becomes applied mechanics. The next is your statics. So static is the study of internal and external forces in a structure. So static is the branch of mechanics and deals with bodies at rest. So static is mechanics with the idealization that the acceleration of mass is negligible in Newton's law. A static is the mechanics of things that don't move. The study of systems in which momentum does not change is called statics. So the other topics is dynamics. Dynamics is the part of mechanics that studies movements and its causes. The study of the causes of motion and change in motion is known as dynamics. So dynamics is the study of how moving objects behave. Dynamics is the study of force and motion of bodies. The vector equations force is equal to mass into acceleration introduces the concept of motion and time derivatives of mechanics. The another is your space. So any geometric region in which the study of a body has been done is called a space. A space is the geometric region occupied by bodies whose positions are described by linear or angular measurement relative to a specific coordinate system. For three-dimensional problem, three independent coordinates are needed. For two-dimensional problems, only two coordinates will be required. The other topic is the time. So time is a concept for measuring the succession and the duration of events. Time is not directly involved in the analysis of problems in statics. So another topic is the mass. So basically the mass of a body is the quantity of matter it contains. Mass differs from weight in that the weight varies with the position on the surface of the earth and with the height above the surface. While the mass remains the same, the engineer's definition of mass, which that is equal to the weight divided by the acceleration of gravity, may be expressed mass in the capital M will be equal to W by G. So both W and G vary for different localities, but the quantity is constant. That is, the quantity of matter in a body is independent of its position with reference to the earth. The weight of a body may be determined by means of the spring balance. Such a balance is the only true measure of weight, since the equal arm balance gives the same weight regardless of distance from the center of the earth. The equal arm balance really measures mass. And the other terms is your particles. So when the dimensions of size of a body are considered to be negligible and are irrelevant to the description of its motion, the body is modeled as a particle. A particle is a point mass or a material point in the abstract sense. A body is therefore represented as a particle if its dimensions are small compared to the coordinates describing its motion as shown in figure 1.3. So example, a cricket ball as viewed by a spectator, a distant aeroplane track by a ground observer, a satellite orbiting the earth and seen by an observer on the earth, a planet as seen from another planet. The other topic is the flexible body. So flexible body that undergo large displacement including large rotations. The large displacement includes rigid body motion as well as elastic deformation. A flexible body system may consist of elastic and rigid components which are connected by joints and or force elements such as a spring, damper and actuators. Then after come to the rigid body. So a rigid body is said to be rigid if the relative positions of any two particles do not change under the action of the forces. In figure 1.4, point A and point B are the original position in a body. After application of a system of forces F1, F2, F3, the body takes the positions as shown in figure 1.4b. A dash and B dash are the new positions of A and B. If the body is treated as rigid, the relative position of A dash, B dash and AB are the same, that is A dash, B dash equal to AB. So many engineering problems can be solved satisfactorily by assuming bodies rigid.